Hi everyone, let's look at some examples of how to compute areas under the normal curve using the TI83 or TI84 calculator. In the first example, they ask us to compute the area to the left of z equals 0.25. This kind of question can be worded one of two ways. They could either say find the area to the left of 0.25 as they do here, or they could even say find the probability that z is less than 0.25. You can do this using a standard z-score chart if you want, and I will provide that for the next exam, but this can also be done using the calculator. The command we would want to do is going to be second distribution, and it's going to be option 2, which is the normal CDF. My advice would be, whenever you have a problem of this form, if they don't kind of give you a sketch, just kind of draw a rough sketch of what the area or the region looks like that you're trying to find. We know that if it's the z-score, that's the standard normal, that means that it has a mean of 0 and a standard deviation of 1. So 0 should be where the bump or the highest part of the graph is. And if we're looking at an area to the left of 0.25, 0.25 itself lies a little bit to the right of 0 on a number line. And then because it says left, you would shade everything to the left. The way that the normal CDF calculation works is it accepts 4 inputs. Those inputs have to be in the order of left bound, right bound, mean, and standard deviation. Okay? When you do a sketch of the region, that's really going to help you to get your left bound and your right bound in the proper order. For those of you using the TI83, it won't give you this kind of display that I have with the 84. You just kind of have to remember that it goes in that order. It's from left to right, lower bound first, upper bound, mean, standard deviation. If I look at the lower or the left bound of my region, it goes all the way to the left. That's like towards negative infinity. Negative infinity isn't a real number, so we can't actually put negative infinity in for the bound. So what we're going to do is we're going to use a large negative number as a placeholder. I know some people do something like with a negative sign and like a ton of 9s. I've seen others that will say let's just do a -1 with a lot of zeros. You can do that too. I kind of like to do -1 second comma E99, which should be like -1 followed by like 99 zeros. And that's about one of the largest negative numbers the calculator can handle, and it will make sure we don't have any kind of round off error. If I look at the upper bound of my region, the shaded part extends up to a z-score of 0.25. So I hit 0.25. Because we're working with z-scores, it's a standard normal, so it's a mean of 0, standard deviation of 1. And then simply go ahead and hit enter. And we see that that probability or area is going to be 0.5987. Let's do another one together. Okay. In the next example, they ask us to find the area to the right of z equals 2.33. On the z-score chart, 2.33 would be right about here, and to the right means we would shade this area here. In order to find that area, I can again do second distribution, go down to normal CDF. My lower bound this time, my shaded region goes as far to the left as 2.33. So it's 2.33. It goes all the way to the right, which would be like towards positive infinity. So I can do a +1 second comma E99. I'm still working with z-score, so it's still standard normal. So it's going to be 0 and 1. Go ahead and hit paste and hit enter on the home screen, and we would get a probability or area of 0.0099. We'll do one last example together. If I wanted to find the area, let's say between -0.51 and +0.32. Again, the best thing you can do is just draw a rough sketch in the beginning, kind of label and shade the region you're looking for. It's going to be second distribution, normal CDF. My shaded region this time goes as far to the left as -0.51. It goes as far to the right as +0.32. 0, 1. Go ahead and hit paste, and I'd find that that area rounded to 4 places would be 0.3205.